Good evening, ladies and gentlemen. This isn't just a pretty picture. This is Camp 18 on the Juneau ice field looking down onto the Gilkey Trench. And I like this picture because it captures balance, a question of balance. How often in our lives we're searching for that elusive balance between work and personal lives. If you stand there where Kristen Tim is standing, climate change is not academic. You see its evidence all around you. And we'll get back to the Juneau ice field in a few minutes. As Steve mentioned, in 1995, I was the convening lead author of one chapter of the second assessment report of the Intergovernmental Panel on Climate Change, or IPCC. I'm sure that many of you have heard of them. Their goal is to advise the governments of the world what we know about the nature and causes of climate change, likely impacts of climate change on things we care about, and mitigation and adaptation strategies. After nearly 1.5 years of work on this chapter of the IPCC report, this was our bottom line finding. 12 words. The balance of evidence suggests a discernible human influence on global climate. And I did not know it at the time, but those 12 words would change my life. And no matter what I do for the rest of my life, those 12 words will follow me to the grave. I learned a lot of lessons in the aftermath of the balance of evidence finding, and I've spent much of the last 21 years pushing back against alternative facts about climate science. Part of the reason I'm here tonight is to tell you that alternative facts are not new. These are some of the alternative facts I've had to address together with my colleagues in the last 21 years. This is one that you've heard very recently, in fact, from the President of the United States, that nobody really knows anything about the relative sizes of human and natural effects on climate. Another alternative fact that we frequently hear is that the Earth's surface and lower atmosphere have not warmed. Then you get this that is actually completely inconsistent with the previous alternative fact. The Earth has warmed, but that warming is solely due to natural cycles or due to some uptick in the sun's energy output. Then we hear this one, that computer models of the climate system overcook warming. They're too sensitive to human-caused changes in greenhouse gases. This is one that we'll get back to in a few minutes. It was first made by Senator Ted Cruz on Late Night with Seth Meyers. Satellite data show no significant warming over the last 18 years. And then again, nobody really knows the causes of climate change. So one thing I'm proud of is that in each case, we have not engaged in science by eminence of position. We haven't dismissed these alternative facts out of hand and said, trust me, I'm a big scientist. These things are wrong. We've done due diligence. We've done the research necessary to address the claim, to see whether it has merit, and have published then the results of that fact check in the peer-reviewed literature. So scientists, like reporters are doing now, have engaged in fact-checking for a long, long time. And I'm going to give you one particular example of that. And again, I think this gets to this issue of what is the responsibility, the role of the scientist in this modern world. And I believe that we need to be accountable. I need to stand up in front of you and in front of a variety of different audiences and tell people in plain English, this is what we did with the money that we received for our research, this is what we learned, and this is why it should matter to you. But in the same way, I believe that our politicians need to be accountable when they stand in the public arena and when they make claims. So here, for example, is a claim that was made by Scott Pruitt, the director of the Environmental Protection Agency. And this was made in response to written questions for the record after his confirmation hearing in the US Senate on January the 18th, 2017. And he made this specific claim. over the past 2 decades, satellite data indicate there has been a leveling off of warming. So that's testable. So Mr. Pruitt's claim looked at the lowest layer of Earth's atmosphere, the so-called troposphere, and looked at these beautiful satellite measurements of temperature changes in that layer of the atmosphere. We have those measurements since late 1978 from a variety of different satellites, and they really do give us the ability to monitor global scale changes in our planet's temperature in this case. So this is what this record looks like. And it's actually the average from 3 different groups, one in Alabama, one in Santa Rosa in California, and one in Maryland. And these groups have looked at these satellite-based measurements of actually the microwave emissions of oxygen molecules. And those microwave emissions depend on the temperature of different layers of the atmosphere. So this particular measurement shows warming of roughly 0.18 degrees Celsius per decade. If you want to convert that into Fahrenheit, over the full 38-year period of the satellite record, that's about 1.25 degrees Fahrenheit warming. So that's the global scale warming signal we're talking about in these satellite measurements. And superimposed on that, you can see a lot of wiggles, a lot of ups and downs. And maybe the most prominent wiggle is that big bump in 1997, 1998. That's the signature of an El Nino. An El Nino is a purely natural phenomenon, and on average, El Ninos tend to warm the planet. So if you look at Mr. Pruitt's claim, again, these are results from 3 different groups. Mr. Pruitt looked at the last 20 years. And if you march back 20 years in time from now, you get very close to that warm spike associated with this natural event. So you have to do a lot of cherry picking to find a period that shows little or no warming. And of course, there's no particular diagnostic value in looking at the last 20 years if you're a climate scientist. You wouldn't throw away the information before that. If you really wanted to understand what's going on, you'd look at the full record, or you'd look at all possible 20-year periods. But what we did is we looked at Mr. Pruitt's claim. The orange information there is from all of the computer models of the climate system in the world. And you can run these computer models with no human influence on climate. And they give you some insights into how large 20-year warming trends should be in the absence of any human-caused changes in greenhouse gases. That's the orange distribution, the orange bell curve that you see there. And the 3 plus signs are the last 20-year warming trends from 3 different observational data sets. So you can see the probability that natural causes alone could explain the warming we've seen over the last 20 years is very small. It ranges from about 1.5% to about 6%. If you look not at this cherry-picked period of the last 20 years, but look at the average of all individual 20-year trends, you get these lines here, and it becomes even less likely that natural causes could explain what happens over 20 years. If you look, as I said, at the full satellite record, the full 38 years, rather than one artfully selected period, so now we're looking at this warming trend from 1979 through to the present, you get this. So again, the orange bell curve is our best estimate from all of the computer models in the world of naturally caused changes in temperature on this 38-year time scale. So we are off the charts. The observations, the warming we've measured and monitored from space is unprecedented in 2 of the 3 satellite data sets relative to our best understanding of natural climate variability. For those of you who like statistics, we're between 5 and 7 standard deviations removed from the mean. So a couple of years ago when there was all this discussion about the discovery of the God particle, the Higgs boson, there was much discussion in the media about the meaning of a 5 standard deviation result. We're now beyond 5 standard deviations out in climate science. And things become even stronger when you look not at one number, the global average, but you look at complex patterns of climate change. We get even beyond this far out on the tail of the distribution result. So again, this shows pretty clearly that Mr. Pruitt was wrong. Even over the last 20 years, there's been significant warming. And when you look at the full record, the warming is off the charts. It is literally unprecedented. So I think it's important to say something about values. When I give public talks, I try and tell people that I am not just a climate scientist. There are also aspects of this problem that affect me as a human being. Let's get back to the Juneau ice field in a few minutes. These are all pictures that I've taken. I've been climbing since I was 18. I've been in beautiful, fragile, high alpine environments around the world, in the Himalayas, in the North Cascades, in the Alps. And over one human lifetime, I've witnessed profound changes in these places. What does it mean if we lose them all? What does it mean if your kids and grandkids cannot experience these places? That gets at not just scientific values, but human values, moral values, ethical values. So, declaring my values, in addition to the scientific imperative to understand the problem and likely outcomes if we do nothing to reduce emissions of greenhouse gases, I firmly believe that there's also some larger moral and ethical imperative to keep these places wild and preserve them. They're not ours. This is where I'm going back in a few weeks' time to Camp 10 on the Juneau ice field. And if you look out onto the immensity of the Taku Glacier, again, climate change is not academic. I go there every year and have done for about 6-7 years now, and you get to see change in snapshots. Go and see these beautiful places now while you can. Just finally, this is the bottom line. We know beyond a shadow of a doubt that by burning fossil fuels, we've changed the chemical composition of the atmosphere. We've changed levels of heat-trapping greenhouse gases. Those changes in heat-trapping greenhouse gases have affected all aspects of our planet's climate: temperature, moisture, clouds, rainfall, and we've identified these climate fingerprints of human activities in many, many different aspects of the observations. The decisions we reach, particularly over the next decade, will have profound impact on the climatic shape of things to come for future generations. Climate science is not a scam, a hoax, or a conspiracy, and I want us to make those decisions on what to do about it, not based on alternative facts, but based on the best available scientific information that we have. I firmly believe that we all lose if we embrace ignorance with open arms. So thank you very much, and I'm going to turn over to Jessica now. I think there are many reasons people deny climate science. There are many reasons why people are skeptical about the science that we do. Some are political, some are economic, some are religious. There's no one unifying theme there. The unfortunate thing for me, I think, is when the ignorance starts at the top, when you have what I like to call trickle-down ignorance. I'm not trying to be funny there. I really mean it. It normalizes ignorance. If you have words like hoax, conspiracy, contrived, phony mess that are used again and again and again by people with big soapboxes, people who thousands, perhaps millions, listen to, it normalizes ignorance, and that makes it that much more difficult for us to do the right thing, to make smart decisions on how to address the problem. Personally, I've tried hard to reach a variety of different audiences. I try to reach people who are skeptical about me and everything that I do, and I try and give them pause for thought. I try and get 10, 15 minutes of their time and ask them to consider, what are the consequences for you and everything you hold dear of being on the wrong side of the science on this one? And how in the end do you want to be remembered? Do you want to be remembered for the amount of stuff you accumulated over your lifetime? Or do you want to be remembered for what you did in the world and whether you made the world an incrementally better place for others? And that's the best you can hope for, to give people pause for thought. Climate change is going to be the backdrop against which all other important geopolitical events of the 21st century are going to take place. And we see those events already unfolding before our eyes. We see, with warming, with sea level rise, changes in where people can live. And if we're even in the ballpark with our scientific understanding of the problem, we're looking, even under optimistic emission scenarios, at several feet of sea level rise by 2100. Think of what that means for the tens of millions of people who currently live at or close to sea level. Think of what 2 to 3 feet of sea level rise means for the fraction of the world's rice production that's at or close to sea level. These things are happening now before our eyes, just like I explained with the glaciers. We're seeing these signals emerge from the year-to-year and decade-to-decade background natural climate variability, and we ignore them at our peril. Human-caused climate change is going to affect every aspect of our lives, our livelihoods, and our health. And again, my perspective is, while we may differ in terms of the best solutions, let's not demonize the science and the scientists. Let's have a respectful dialogue on the what to do about it, but let's not pretend that the science is fake. It isn't. Show your passion. I've spent 25 years of my life doing this stuff, trying to understand the complex climate system. Now imagine one day you wake up and your new boss, the new Secretary of Energy, dismisses everything that you've learned and done and published in the last 25 years and says, quote, "In my opinion, climate change is due to ocean waters and this environment in which we live." You have a clear choice. Do you go back to your office and close the door and hope that all the bad stuff goes away? Or do you speak out publicly and say, this is wrong? This is not our best understanding. In my opinion, you have to push back. Why even bother doing what you do if you're not willing to defend that technical understanding when it comes under unjustified political attack? I would be better off in the middle of the ice field, climbing, happy. That would be great. You got to defend what you do. So that's one lesson that I've learned, but I don't think there's one unique way of doing that. Each of us has different strengths and weaknesses. Some are good at doing the science and pushing back that way. Some are good at communicating publicly. Some are good in organizing communities and empowering teachers and educators. I'm so darn grateful for the work that Climate Generation does in empowering teachers and students. So find what you're good at, find what you're passionate about, and use your voice as effectively as you can. I would say that scientists have different comfort zones. My comfort zone is remaining within physical climate science. That's what I know best. That's what I do. That's what I love. So I'm very careful when I speak in public to delimit the boundaries of my expertise and tell people this is something I know about. I've studied it. I have opinions on the economics, on the politics, but I'm not informed on these issues. Sometimes people move fluidly across those boundaries without declaring where they have expertise and where they don't. In my opinion, that's not the model I want to follow. A couple of more words about how to do this communication stuff. You know, one very powerful narrative out there is you are just in it for the money. All climate scientists do this stuff in order to become fat cats and profit at the public's expense. That bugs me a lot. Again, let's get back to the passion, the joy. The reason you do this, the reason you go through this long and arduous apprenticeship is not to get rich. It's not to alter world systems of government. It's for that joy of understanding, for that sense that maybe once or twice in your entire scientific career, you have a tiny piece of the puzzle that nobody else has, those aha moments. That's why you do it. Your currency is understanding. And that's what you're judged on by your peers. At the end of your career, people look at you and ask, did he or she get it right? Did they get the science right? You're not judged by how much stuff you have or how much money you have or how much influence or power you have in the scientific community. It's did you get the science right? That's our currency. And conveying that is a challenge because that's not the currency for much of the rest of the world. Again, I'm not knowledgeable on the solution side of things, so let me delimit that boundary there. But I would say this, I'm often asked this question, what can you do to make a difference, to shift the needle? And the answer, my personal answer, is become informed. Education, education, education. I firmly believe that we need an informed electorate who understand the basics of this issue and what's really at stake here, what likely outcomes are if we do nothing to reduce emissions of greenhouse gases. And the only way we're going to get there is through organizations like Climate Generation, providing the tools for educators to give kids the best available scientific information. I don't see us shifting the needle if we continue to have trickle-down ignorance and don't push back against that. So education is the greatest good. And when I give public talks, inspiration is a two-way street. I always come away inspired by seeing dedicated, smart young women and men who want to make a difference in the world. They understand this problem. They understand this is the world, this is the climate system they're going to inherit. They're going to grow up in this world, and they want to influence the outcomes. Give them the tools to be successful and to understand the problem.